Hello, welcome back, and let's just go ahead and get started right away. You can see here I've pulled up the code that we were working on last time, and one of the things I want to start off with, right off the bat, two things. The first is just a little bit of precaution. I said you can run this chip right off the bat, which you can. It's not plugged into anything. It's just got an LED on it hooked to my USB. But I have in the past had an occasional problem where if you're working on a one of those plastic tables, those folding tables, and it's in the middle of winter and the humidity is really, really low, it's possible to get a static charge from those and potentially fry a chip, which we don't want to do. So the first thing we're going to do right now is we're going to plug this guy into a breadboard, and I'm going to do that now. I'm just going to insert it right there, starting on pin 10, and that way I don't have to worry so much about it getting a static charge. It'll be protected. The pins will be somewhat protected by the breadboard itself. The next thing I wanted to address on our code, actually let's just get a fresh copy. Let's take and copy this so we don't have to lose our original and do a file new. Okay, paste it in there. Alright, so now we're going to work with our copy here. Stretch it out a bit. So this LED is hooked up to pin 13 permanently. It's not going to move. Okay, I mean that's it. It's hardwired in. It was built that way. And I've originally declared this as a variable, and variables imply that you can vary them. There's another way to do this, which would be better for this, and we should get into this habit. Is that pin is not going to move. It's going to be constant. So let's make it constant. And that's simple enough by just putting in const in front of the integer, and now you've made it a constant integer. Okay, it's not going to vary. It's fixed on pin 13. And speaking of variables, let's make a real variable we're going to change. So let's make an integer variable, and let's call it delay spelt funny, and let's go ahead and make it worth something right now. We'll change it. It's a variable. We can change it anytime we want. Okay, so I've created a variable called delay, and I've set it equal to 200. In this application, if I were to replace these 500s with the word delay, we should get rid of this. We'll comment it later when we're done because it's not going to be 500. So now it's going to substitute the value 200 into our delay function, so it's going to have a delay of 200 milliseconds. If I load it up, we should see it go. And there you go. So now it's flashing on and off 200 millisecond intervals. So the codes we're going to be working on, there's so much we can do. I'm going to focus on code examples and building things that's going to get us to a robot. And one of the things that we do an awful lot in robotics is for loops, or a variety of different loops, but for is one of my favorite. We're going to turn for a distance, we're going to scan for a duration, we're going to do any one of a number of things in robotics for a specified time depending on the condition. So working with a for loop is probably a great place to start, and we can play with it with just our light. Let me pull up. If we go to the Arduino page and look at the for statement, you see that a for statement has an initialization, a condition, and an increment. Okay, we need to have all three of these in our block, and I'll show you some variability real quickly when we do it. So let's look at our code again. And we'll just pull it right here, sort of side by side. So let's create one. Here's a for. What do we want to do? Let's play with delay. Delay. Let's start it at equal to we'll go quick. 100. Okay, we're going to start at 100 millisecond delay. We're going to take delay down to a point where it's say greater than 10. Okay, we want to keep it between 10 and 200. And what are we going to do? Let's put in two minus signs, which means subtract one value. So it's going to start at 100. That's every time it loops, it's going to 99, 98, 97, 96. Alright, now these for loops have their own sets of brackets. Okay, so we need an open one and a closed one. And generally speaking, for good readability, you really should tab those in or give yourself some spacing, because now when you look at this code, you can see it makes pretty good sense. In this loop section, we've got our major brackets holding it all together. The first thing that happens inside of it is we got a for loop. Oh, by the way, it's got its own set of brackets, and we've set it in so you can clearly read it. So if I load this up, we should see a light go faster and faster and faster, and then reset. And oh, you can't see my video. Let me make this window smaller. Okay. Now once again, we have on the video, it looks a little funny because of the frame rates of the camera, but looking down at your board and with me looking at mine, it's flashing absolutely gorgeous. Okay, it's going faster and faster and faster than resetting. Let me show you this too. So let's say we don't have to stick with an increment of 1. I can make it something different. I can make it, let's make it an increment of 10. Okay, so that would be delay is equal to delay minus 10. Looks good. So now we should see it go down even faster. Tell you what, to make it so we can actually see it, let's bring that up to 200. So we're going to start at 200 milliseconds, and we're going to go down to 10, and we're going to do it at an increment of 10. So hopefully it works fine. And it goes faster and faster and faster and faster and faster and resets. Okay, so it works exactly like we told it to. Now, I said that you don't actually have to have this here. I'm going to Control X that out of there. I could put that right here if I want to, if it makes it easier for me to read or understand. Let's go ahead and do it and see if it works. And once again, we get the effect we're looking for. Okay. Usually though, if you can, you should put the incrementals in the parentheses. I don't recommend doing it, and you can't. Like I said, you can, but this all makes beautiful sense. When I see that for loop, I can figure out everything that's happening right then and there in that single piece of code. Let's do one more thing. Let's take and let's say I want it to go down and then up. Okay, so this first block goes from 200 down to 10 in increments of 10. The second block, we want to go from 10 to 200, less than 200. Okay, and we want to add 10. Right? So it's going to go from 10, so this one goes from 200 down to 10, or actually 11, it's going to be greater, but then it's going to start at 10, and it's going to go up to less than 200, or 199, or actually it's going to be 190. And then it's going to break from this loop and go back up to this loop. So we should see a nice increment going down and then back up. Let's see how well it works. And it's going down and back up. And down and back up. So it works perfectly. Let's see, we should put some comments in here, as I said. So let's do, what is this? This is our variable, oh my goodness, variable for holding delay times. And this is going to be, I can actually put that in the next line down, right there. Let's tab it in a couple of times. This is a for loop, bringing time down, bringing delay down. And then down here, we have a for loop bringing delay back up. Okay. So does that make sense? What I'd like you guys to do before we move on is you should be, by this time, I'm hoping, you should be able to do this exact piece of code or something similar to it on your own. I'm going to save this. I'll put it back in our directory. Okay, class code, let's move it down. And let's call this up and down. Okay. And what I'd love you guys to be able to do is to create a new one, close that, and write a piece of code that works. You should be able to flash that light at least using your own code. The next block we're going to talk about seeing the values come up in the serial window so we can actually watch it display the numbers that are being generated by that variable. So that's it for now, and I will see you soon.